Hi everyone, welcome back. Someone asked me to do some equations, some differential equations, and so here's an introduction to differential equations and what they are. So I don't want to go into great complexity, I don't want to go into trigonometry and other complications, but to start with, just what makes a differential equation a differential equation. The moment you see dy dx, you have a differential equation. So on this one here, it's written as dy dx equals. On this one, it's got dy dx in the middle of the equation. Mostly what we're going to do with is usually when the dy dx is in the equation. You can even go to d2y dx squared, you can get second and even third order differentials, but we're only talking here about the first order where it's only got dy dx. So what's the whole idea? I've written over here, what we're going to do is we want to separate the variables. So why are we going to separate the variables? If I tried to get the integral for this side here to get rid of the derivative, I'd have to then get the integral of that side. And the problem is here, I've got the two variables. I've got x's as well as I've got the y's. So the trouble is, we don't have, well, most people watching this video won't have the technique as yet to be able to figure out how to do that. So we're looking at how can I undo a derivative. So let's have a look at what's possible. If we separate the variables, that means we put everything that says y on the left and everything that says x on the right. It really doesn't matter which side as long as the y's are all together and the x's are together. So let's have a look at what's happening here. I can write that as dy, and if I times both sides by 3y minus 2, I'm going to be a little bit fussy for a moment, depending where you are watching the video. Some people are fussy and they want a bracket around it. So how do I get rid of a divided by 3y minus 2? I use a times 3y minus 2, and of course they cancel out. Now some of you watching will be able to just do that in your head, but have some patience for a moment for those who don't. So if I come over this side and I times this side by 3y minus 2. So what I've done is I've removed all the y's from the right hand side, so everything now that says y is on the left hand side. So I've got 3y minus 2 with a bracket around it. Please don't forget the brackets. In Australia, so many students leave the brackets out and then mathematically do silly things as a result of it. So on this one here now, I've still got the dx here, and I'm going to write all extra steps. Once you get used to doing this, you can do it very quickly. So this is only that very first basics of what to do. I've now got to divide by dx. How can I get rid of a divide by x? I do still talk about the opposites to both sides. So the opposite of dividing by dx is timesing by dx. Technically, dx is not a fraction, and dy dx is not a fraction. We're talking about the limit of a fraction. But for practical purposes, if I multiply this side by dx, I multiply this side all by dx. And again, watch out for the brackets that so many people leave off and they just make silly mistakes. So in some ways it's not good to be able to cancel those. We could have just moved the dx. But for practical purposes, a lot of people look at it as cancelling. So now I've got 3y minus 2 with a dy. So all the y's are written on the left hand side and all the x's are written on the right hand side. Now here's where it's nice. This is one of the things I like about differential equations. Is you now can, if you get the integral of the right hand side, you can get the integral of the left hand side, because now this only says y and it's got what we want there, which is with respect to the letter y, and over here with respect to the letter x. So now I can just get that integral, and the integral of 3y is 3y squared on 2. The integral of minus 2 is minus 2y. Technically I should put plus a constant, but in a moment I'm going to have two constants, so sometimes I'll call that constant 1. This one, the derivative of, the antiderivative of 2x is x squared, and then the antiderivative of 1 is x. And again, I could put another constant there. By the way, if this turned out to be 2 and 6, we'd have it as 4. If we had, you can just put any values you want into those situations and you find the final constant. But at this stage, we're not getting the final constant and a specific constant. We're just getting a general case. So now I could write that as 3y squared on 2 minus 2y equals x squared plus x. And I could have another constant. I could have called it constant 3, or if I called them 1 and 2, I could just call that the constant. Now this is the general solution to that differential equation. So all we've done is remove the dy dx out of the situation. So now we have a relationship between y and x, which gives us a much easier situation to handle mathematically. So that one's fairly straightforward. Let's have a look at this one now. A little bit more complicated. I could simply, if I wanted to, go dxy squared dy and move the dx over, so we'd have 2dx. But then I've still got an x over here as well. I'm still going to treat it as if people aren't that confident with it. If I divide this side by x, I divide that side by x. That's what I call opposites to both sides. So the opposite of timesing by x is dividing by x. I could have divided by 6 if I wanted to, but I just want to get rid of that x. So the x's cancel and I've got 6y squared dy, and I've got 21x dx. Now I've got all the y's on the left hand side, all the x's on the right hand side, or vice versa, you can go the other way around. So that's separating the variables. Now I can look at the question, I can just say I want the integral of this side, and it didn't work, integral of this side and the integral of that side. What have I got now? The antiderivative of 6y squared. Anyone that's not confident still, most of you will be. I could write that as 6y cubed on 3, so you increase the power by 1 and you divide by the power. I call them the i's. The reason I refer to them as i's is everyone knows when you're integrating to increase the power. But in assessment, so many students muck it up and by accident, even the brightest students I've ever taught, will muck it up and go the wrong direction, and instead of writing a 3, they'll write a 1. So I have this little thing I keep mentioning to students with i's. When you're integrating, we're going to increase the power. And if it's a differentiating, we're going to decrease the power. So I talk about the i's and the dd's to try and stop people from making silly mistakes. So I increase by the power and I divide by the power. And I could go plus c1. On this one, this is a log derivative. So let's have a look what that log derivative is. It's 2 by the ln of the absolute value of x. So 1 on x would have become, the antiderivative of 1 over x is the ln of x. So now I can have plus c2. Could rewrite it all and go, now that's 2y cubed equals 2 ln of x. And instead of going c1 and c2, I could go c3 if I wanted to, just some constant. And I could tidy it up a little bit and I could go y cubed and divide both sides by 2. And then I'd have ln of the absolute value of x. And then if I wanted to be fussy, I could call it constant 4. But the whole way through, if I wanted to, I could have just had a constant there and having it there at the end. So this is a general solution. What we've done is remove the dy dx out of the original equation. So now we have a relationship between y and x. I could get fussy and I could do all sorts of things to it. I could make it more specific and I could go, if I get rid of that 3 there, how do I get rid of a cube power? Be fussy for a moment, I raise it to the power of 1/3. So the opposite of a cube power is a cubed root. So all I'm doing is I want to take the cube root of that side as well, which is the ln of the absolute value of x plus the constant which we had there, which is 4. So I could write it there and have it as y, which is nice because then you can put in any x you want and very easily and clearly work out what the y was. So there's an introduction to differential equations. Basically the idea is, how do I get rid of a dy dx out of it? And the simplest way is put everything that's y on the left and put everything that's x on the right, and then you can just do the antiderivative and get the answer. Thank you.